Hi Year 12s! Today we are looking at the chain rule. The chain rule is used to help perform more complicated forms of differentiation. We use the chain rule when there is a function within a function. The formula for the chain rule is provided in the formula sheet. dy dx equals dy du times du dx. At first glance, it may seem a little confusing, but the basic idea is that we separate out the function within a function and differentiate them separately. For example, from the 2014 Exam 1, Question 1b, f of x equals root x squared plus 3. Find f dash of 1. To find f dash 1, we first need to find f dash x. The first thing to do here is to rewrite the equation in power form. This means converting the square root to a power. F of x equals x squared plus 3 all to the power of a half. To make life easy, I'm going to replace the fx with a y, so that I can use dy dx. There is no harm in doing this as long as when you write your final answer, you use f dash x instead of dy dx. So that gives us y equals x squared plus 3 to the power of a half. Now, the contents of the bracket are my u term. U equals x squared plus 3. I now differentiate u with respect to x. This means I differentiate the function as normal. So, as we saw in the first calculus video, I bring the power down and take 1 away from the power, giving us du dx equals 2x. This gives us our second term from the equation on the formula sheet. I now need to find dy du. To do this, I need to first express y in terms of u. Before, I wrote that u equals x squared plus 3, so in my initial equation, I can replace x squared plus 3 with u. Y equals u to the power of a half. Now, I differentiate as per usual. Bring the power down and take 1 away from the power. This gives us dy du equals a half u to the power of negative a half. You can express dy du with positive indices now, or you can wait till later. It doesn't make a difference to your final answer. Just be aware of the negative power. This is the first term from the equation from the formula sheet. So remembering this, we get dy dx by multiplying du dx and dy du. So for this example, dy dx equals 2x times a half u to the power of negative a half. Remember, here u equals x squared plus 3, which gives us dy dx equals 2x times a half x squared plus 3 to the power of a negative a half. 2 times a half gives me 1, so I can get rid of the whole numbers. dy dx equals x times x squared plus 3 to the power of negative a half. You should always write your answer with positive indices. Following the steps on the screen, we get dy dx equals x over x squared plus 3 to the power of a half. We should now replace the half with a square root. This isn't necessary, but it does make it look nicer. dy dx equals x over root x squared plus 3. We now need to rewrite our answer in terms of f dash x. To do this, all we do is replace dy dx with f dash x. This is not your final answer. Students always make the mistake of finding the derivative and moving on. The question asked us for f dash 1. So far, we only have f dash x. Now that we have f dash x, we just substitute x equals 1 into this function to find f dash 1. As you can see, the maths here is pretty straightforward, giving us a final answer of f dash x equals a half. Thanks for watching and happy studying!